Okay, now beta, before we start off with composite sailing, uh, do you know what is parallel sailing, beta? Parallel sailing?
Sir, who is sir, along the parallel of latitude departure upon D long equals to course mean let.
Very good, beta. Very good. Yes, you are right. Parallel sailing is when we move along the parallel of a latitude, and उसमें हम जो formula use करते हैं वो बिल्कुल सही बोला आपने. Departure upon d long is equal to cos of m lat or cos of mean lat. In this case, the latitude will be the same. So our course is either 090 or 270. So this is what we use in composite sailing along with the great circle sailing. So let's see this formula briefly and then move on to the concept of composite sailing.
Let us quickly brush up our concepts of parallel sailing, which I'm sure all of us are aware of. Now, when a vessel sails along a given parallel of latitude, that means along an easterly course that is 090 degrees true, or a westerly course that is 270 degrees true, the sailing is referred to as parallel sailing. We already know why it's called parallel sailing, because you are moving along a given parallel of latitude. Now, departure is the east-west distance between two places expressed in nautical miles. So please note, it has to be expressed in nautical miles, and it needs to be the east-west distance between the two places or points. Now we have a parallel sailing formula, which gives us a relationship between d long and departure, and we all know it. Cosine of latitude is equal to departure upon d long. Obviously, this cos lat cosine is a trigonometric ratio. So obviously the units of departure and d long will be same. So here we have the world map on the screen. Let us say we need to depart.
Beta, you remember this formula? If you want, you can note it down. That is the parallel sailing formula. Now, departure in this case, beta, is the distance we travel on the parallel sailing, distance we travel along the parallel of a latitude. So to calculate the distance, you need to know what is the d long between the two positions and what is the latitude on which you are moving. So putting these two things, you can easily calculate the distance between your initial and final positions.
Same. So here we have the world map on the screen. Let us say we need to depart Tokyo in Japan, which comes up on the screen marked as point A, with its coordinates also showing up. And we need to reach Seattle in United States. It also comes up on the map marked as point B, with coordinates of the Seattle also showing up on the screen. Obviously, our preferred route shall be great circle sailing to save on time. And in this case, you can see it shall be across the 180th meridian, across Pacific on an easterly track. Now let us quickly draw a PAB triangle between Tokyo and Seattle on the globe. Here we have point A representing Tokyo. Here we have point B, Seattle in United States. We join them with a shorter arc of great circle. So this is from A to B, the arc great circle track between A and B. This is the vertex of this great circle track. So we have the GC track from A to B as well as the vertex of the.
So this is the actual PAB triangle on the Earth surface, beta. P is the pole, A is our initial position, B is our final position. Now, Just a minute, let me highlight the mouse. So you can see A is our initial position, then B is our final position. AB is the great circle track between them. And if you see this dotted line going through the earth and coming back, this is the complete great circle on which we are moving. Papa alpha side is the colat of position A. Papa bravo side is the colat of position B. And the vertex is here, beta. You can see all the parallels marked here. And you can see that the highest latitude this track is attaining is somewhere here. Right, beta? Up to here, everything clear?
Yes, sir.
Yes, sir.
Okay, all right.
This track. Now we can see in this case, the GC track is easterly because the D long from A to B is easterly. Let's now draw the meridians of A and B. So the two meridians come up on the diagram, and what we get is a PAB spherical triangle, which we all know that if enough information is available, can be solved. Now this white track out here is the rhumb line track between the two locations, and we can see that the rhumb line distance obviously is greater than the GC track, and therefore the preferred track shall be the GC track from A to B.
So you can see this rhumb line track also, beta. The rhumb line track is a longer distance, but the advantage is that you see rhumb line track is going much down south. The highest latitude you are going to attain or moving on a rhumb line track is the latitude of B, no more than that. But if you follow a great circle track, the latitude will be much higher than the latitude of both the positions A and B. So this is the advantage and disadvantage of the great circle track compared with the rhumb line track. So there is a saving in distance in the great circle track, but at the same time you may go closer to the danger or you may pass over land, like in this case we are passing over this point.
Preferred track shall be the GC track from A to B. For the sake of clarity, let us see how these two tracks, that is the GC track and the rhumb line track, would appear on a Mercator chart. Now, this is how the tracks would appear on a Mercator chart. On Mercator chart, the GC track would be a curved track and a rhumb line track would be a straight line track, we all know.
So is it clear, beta? The first thing which we saw was on the globe on the actual earth, and now this is how it is going to appear on a Mercator chart. Okay, let's now proceed ahead and see mnemonic chart, how it will appear on a mnemonic chart. Have you seen a mnemonic chart on board, beta?
Yes, sir. Beta.
Okay, all right. Usually ships which go in transocean passages, they have mnemonic charts, set of mnemonic charts to help in planning the Great Circle passage. So let me show you this path on Great Circle, on mnemonic chart.
That on Mercator charts, because the meridians are parallel straight lines, therefore the rhumb line tracks are straight lines. Now here it may appear that GC track is a longer distance, but that is not so. It is the GC distance along the GC track which shall be the shortest distance. How would these two tracks look on a mnemonic chart? Let's look at that. Now here we have how it would look on a mnemonic chart. On a mnemonic chart, it's polar mnemonic. GC track would be a straight line and rhumb line track would be a curved track. So hope these two comparisons also bring in clarity.
So this is how it appears on a mnemonic chart, beta. On a mnemonic chart, the Great Circle tracks are straight lines, and rump lines are curved.
About how these tracks appear on different projections. Now, having appreciated as to how these tracks appear on different projections, we come to the most important part of our discussion. And for that, we go back to the PAB spherical triangle constructed between Tokyo and Seattle a while back. Now on this globe, we can see this PAB triangle with this one being the GC track between A and B. On examining this track, what do we see in this part of the track? We see that some part of the track appears to be passing over land or maybe non-navigable waters. Now, this could be one reason, or there can be other contributory factors also, which may force a vessel to decide on the highest latitude that it would not like to cross during her voyage. The highest latitude that the vessel would like to reach and not cross is referred to as limiting latitude. Let us say, factoring in all the requirements, in our case, let us say we decide to limit the latitude to 50 degrees north. Here comes the parallel of latitude of 50 degrees north. And now obviously it's very clear that the vessel cannot go from A to B along the GC track because.
Okay, so now we see this limiting latitude on the chart beta. So in this case, they have selected 50° north parallel of latitude as the limiting latitude. So how is this limiting latitude selected? Now, if there are any non-navigable waters or the vessel's track is moving over land, then certainly you will be able to get it from the chart that my track is clear up to which particular latitude. Otherwise, if you are in open sea and there are no restrictions otherwise, the limiting latitude is decided by looking at the routing charts of that area and the sailing direction, the pilot books. So these sailing directions and routing charts, they give us information like what is the frequency of bad weather in that particular area, what is the extent of icebergs, so up to which parallel of latitude are we expected to get icebergs, uh, how is the visibility condition with respect to the latitude, after which particular latitude we will be having more frequent instances of restricted visibility. So we take care of all these things. We can check out the weather in the area. The routing chart will tell us that where it is expected that the weather will be very bad. We can check the swell heights, the wave heights with respect to the latitude, and this helps us in deciding. The master and navigating officer can then decide that which is a safe latitude for my ship to follow. So in this case, they have picked up this 50° north parallel of latitude. So we do not want to cross this latitude. We do not want to go northwards of this particular latitude. Now the easiest possible option appears to be. So what could be the easiest possible option, beta?
सर आधा जीसी हो जाएगा फिर 50 डिग्री मैक्सिमम जो आएगा वो 50 लेट के बाद फिर डिसेंट करना शुरू कर देंगे.
Right. So the easiest option which comes to the mind is you keep on following the GC track. As soon as you reach here on your limiting latitude, now you follow the parallel track. That means moving along the parallel of a latitude of 50° north. And once you reach back here, again follow the GC track and reach to your destination. That seems to be the easiest possible way. But there is another possible way which, if we follow, will give us even shorter distance than this, and at the same time will not cross the limiting latitude also. So what is that way with which we can avoid latitudes higher than 50 and follow a track which is even shorter than this. Let's see.
Some part of it is crossing the limiting latitude. In such cases, to strike a balance between the shortest possible distance and also meeting the requirements of not crossing the limiting latitude, the vessel may use combination of sailing. In this case, combination of great circle sailing and parallel sailing. What does the vessel do? Vessel figures out a GC track whose features include A, it passes through departure position A. 2, it has its vertex on the limiting latitude. So here is the GC track passing through A with its vertex being here on the limiting latitude.
So beta, you can see now that we have not followed the original great circle track. जो पिंक कलर का ट्रैक था, original GC track, we have not followed it at all. What we are following is a great circle track which passes from our starting position A and which has its vertex on the limiting latitude. जो पिंक वाला ट्रैक था उसका वर्टेक्स तो हायर लैटिट्यूड्स में था, पर जो ब्लू कलर का ट्रैक अब हमने बनाया है, दैट ट्रैक हैज इट्स वर्टेक्स ऑन द लिमिटिंग लैटिट्यूड. So did you understand it up to here, beta? Any doubts up to here?
No, sir.
Okay, good. Let's proceed ahead.
V1 represents the vertex of this blue GC track, AV1. Now, this is a GC track, obviously. This is the meridian of V1, the vertex.
Now, beta, if this point V1 is the vertex of the blue color great circle track, can you tell me what will be angle V1? Angle V1 in this diagram?
90 होगा
So
सर.
90 degree.
Very good. So angle
90.
V1 would be 90 degrees. We know at the vertex the great circle track is east-west and it cuts the meridian at 90-degree angle. So this will be a 90-degree angle.
We all know that this meridian will make an angle of 90 degrees at V1. So what do we get? We get this shaded right angled spherical triangle.
So हमें अब एक triangle मिल गई है, Papa Alpha Victor 1. So PAV1. So we will be solving this triangle in composite sailing, and it's a special spherical triangle. All three sides are great circles and it has a right angle at Victor 1. So ये पहली triangle है जिसे हम later on solve करेंगे. First we'll understand the concept. So ये पहला great circle track हमने follow किया. Now after this we will follow another great circle track at the end of our passage. So let's see that also.
PV1A is a right angled spherical triangle. Likewise, we figure out a GC track passing through B, again having its vertex in the limiting latitude. So you can see this one. Here is the vertex of this GC track marked with V2. So what is BV2? It's an arc of great circle passing through B, having its vertex in the limiting latitude.
So बेटा आपने देखा जो थर्ड लास्ट में जो लेग हमने फॉलो की, पहली लेग हमने फॉलो की अल्फा टू विक्टर 1 एंड जो लास्ट लेग हमारे पैसेज की होगी दैट विल आल्सो नॉट बी अलोंग द ओरिजिनल जीसी ट्रैक. जो पिंक कलर का ओरिजिनल जीसी ट्रैक था उसे हमने बिल्कुल छोड़ दिया है. What we have followed is a new blue color GC track and it is such a great circle which passes from B and has its vertex at the limiting latitude, which we have represented as V2. So the blue circle here which we see arc of the great circle is such a great circle which passes from our destination point B and has its vertex on the limiting latitude. So this is also clear beta up to here?
Yes, sir.
Okay.
Here is the meridian of V2, and obviously this will also make an angle of 90 degrees with the GC track. We get another right angled spherical triangle, PV2B, shaded out here. Now we get two right angled spherical triangles, PV1A and PV2B.
So you see beta, we have another special spherical triangle, Papa Bravo Victor 2. So ये दो spherical triangle हमारे पास आ गई हैं, and from our starting point A, we go up to V1, Victor 1. From V1, we follow the parallel track and go to Victor 2. And from Victor 2, we follow the second great circle track up to our destination. So this is the track which we follow during composite sailing. Now you can see we have not crossed the limiting latitude at any location. We are always within 50 degrees latitude. We have not crossed it. And secondly, the distance traveled now is shorter than following the pink color track and the limiting lat. I'll explain to you how the distance is shorter in another diagram. Later on, I'll show you this diagram. So this is our composite sailing track. We first do GC sailing from A to V1, then we do parallel sailing from V1 to V2, and we do next leg of our great circle sailing V2 to Bravo B. So all clear up to here, beta?
Yes sir. और सर ये V1 से V2
सर
लेके
जो
अपना पैरेलल सेलिंग हो जाएगा.
Yeah, that's right, beta. V1 to V2 will be parallel sailing.
Okay sir.
सर जो ये V1 है, it is the vertex, so right angle triangle दोनों साइड बनेगा सर कि एक ही साइड बनेगा?
दोनों साइड बनेगा बेटा. It will be 90 degrees on both the sides.
So angle V1 on both side, angle V2 also both side 90 degree.
Yes, it will be 90 degrees on both the sides.
Okay.
Sir, but the track
Okay, sir.
is parallel of latitude and the other one is GC.
Right.
How it will be 90 degree on parallel of latitude, sir?
Okay. बेटा पापा टू विक्टर 1 जो है ये क्या है?
That is meridian, sir.
मेरिडियन ऑफ दिस प्लेस.
वो
और ये जो ऑरेंज कलर की लाइन हमने ड्रॉ की है ये क्या है?
Parallel of latitude, sir.
So one is meridian, another is parallel of latitude. They will intersect at?
Meridian.
90 degree
They
angle.
also
beta.
intersect at 90 degrees.
Right. So this angle will be 90 on this side also and on this side also. Both these angles are 90 degrees.
Okay, sir. Okay.
Okay. Same is the case here. The angle V2, whether it is between this shaded triangle Papa Bravo Victor 2 or on this side, it will be 90 degrees.
Okay, sir.
अब बेटा मेरे माइंड में एक डाउट आ रहा है कि ये जो बीच वाली ट्राइंगल है पापा विक्टर 1 विक्टर 2, इसमें भी तो 90 डिग्री के दो एंगल बन रहे हैं. इसमें भी नेपियर रूल लगा देते हैं?
No sir, so it is not a great circle.
it's not a spherical triangle.
Spherical triangle.
वेरी गुड बेटा, वेरी गुड. सो आप ये समझ गए हो अब. ये जो बीच वाली ट्राइंगल है दिस इज नॉट ए स्फेरिकल ट्राइंगल. व्हाई? बिकॉज इसकी जो V1 V2
Parallel of
साइड है
latitude.
it is not a great circle, it is a small circle. It is a parallel of latitude which is a small circle.